Hi, welcome. We are doing 11.3, which is on page 46 in your note guide. This is a review from your notes from a day ago. It's a square and a triangle. We know how to find the area of it, but finding the perimeter and area when we don't have a side. Can we figure it out using our special right triangles, 30, 60, 90s, 45, 45, 90s, and what we know about the angles we're going to create here. So, do we know the formula for the area of any polygon? So, yesterday or the day before you should have learned area of any polygon is going to be equal to 1/2 A, which stands for apothem, and P stands for our perimeter. Okay, so things that we wanted to remember from the day before, when we had maybe an equilateral triangle, or you had a regular hexagon. These are shapes where you are going to have a 30, 60, 90, 40, 30, 60, 90 triangle. Okay, if you have a square, so you had a worksheet on the page before, if you did that, a square is going to be a 45, 45, 90. This is February of 2021. Okay, so those are the ones that we have to kind of memorize. We're a little blurry. There we go. Now here we have a square. We have a square. I know that this right here is the radius, I think. This is 12. So I'm going to pull this down right here. This is now going to be my apothem. This created a 45, 45, 90. So I know that this side here is x, this side here is x, this side here is x root 2. I always put in my general form. X root 2 is where the 12 is. That's my equation I'm going to start with. So over here off to the side, I'm going to say, well, x root 2 equals 12. We have to divide both sides by root 2. Again, you guys can pause, finish these two on your own, come back and check. Now, every time we divide by root 2, the same thing happens here, especially when it's even. Root 2 over root 2, to rationalize our denominator, I get 12 root 2. 2 times 2 is 4, square root of 4 is 2. I'm just going to divide that in half every single time. So I end up with 6 root 2 for my sides. So this side over here is a 6 root 2. This here is a 6 root 2, which means that would be a 6 root 2, making the entire side right here 12 root 2. Okay, now you have two ways you could do this. It's a square. You could do 12 root 2 times 12 root 2. 12 times 12 is 144, times 2 is going to give us 288. I could also use the formula we just learned yesterday because it is a polygon. Area of a polygon is 1/2. My apothem here is 6 root 2. And then I have to use my perimeter. Well, if this is 12 root 2, 4 times, I'm going to end up with 48 root 2 meters. So again, 12 perimeter, all 4 sides, 48 root 2. If I did 12 root 2 times 12 root 2, I did that in my head a minute ago, I got 288. But to see that it does work, 48 root 2, well, half of 6 is 3, times 48 times 2. 3 times 48 times 2, I end up with 288 meters squared. Or 48 times 6. Let me work it out. There we go, 288. I got the 6 from the 3 and the 2 here. Okay, see that you can do the same thing over here. I'm going to use a bunch of highlighters in a minute, so if you wanted to get those highlighters out in color, you can as well. So over here I have an equilateral triangle. I'm going to draw my apothem. This one's nice because if this is my apothem, this is my x, this is 2x, this is x root 3. So knowing your general form of your 30, 60, 90. Well, if 2x is 10, x is equal to 5, which is my apothem here. And here I have 5 root 3 for my longer leg. Well, if that's 5 root 3, this is 5 root 3, making my entire length here 10 root 3. So my perimeter again is 3 times 10 root 3, giving me 30 root 3 for my perimeter. I could do that over here too. I didn't write it, but it was 4 times 12 root 2. So that's where I got my perimeter here, my perimeter here. Now area equals 1/2. And we have a lot of ways to solve for triangles. Now we have a lot of different formulas to figure out the area of a triangle. And it really, any one you want to use, you could use. You just have to pick what's the best choice with the given information. And in this case, area equals 1/2. Apothem perimeter. Apothem is 5. Perimeter is 30 root 3. I would take half of 30, so I get 5 times 15 root 3, giving me 75 square roots of 3. Make sure you put your units here. It's inches this time, so inches squared. So hopefully you remember some of that. I know I did a little bit fast, but you did have a practice page. I can't remember if it's assigned for sure or not, but it's a good practice. Okay, so going on to that's review. Going on to the next part, what we're talking about today is perimeters and areas of similar figures. But this is a pretty nice section. I actually kind of like this section. I'm going to show you and I'm going to color code. Compare, the sides will be in pink, the perimeters will be in blue, areas will be in green. I have a pen and a highlighter in each color. I want to find the side, perimeter, and area of each of the figures here. So I want to compare them. The side length of the first one is 3 inches. The side length of the second one is going to be 6 inches. And the last one here, the side length is 9 inches. Go ahead and fill in the perimeter and area for each of those shapes right now. Perimeter here is going to be 12 inches. Perimeter here will be 24 inches. Perimeter here is going to be 36 inches. Now green, area is 3 times 3, it'll be 9 inches squared. 6 times 6 will be 36 inches squared. 9 by 9, we get 81 inches squared. Okay, so now I want to compare. I want to see what happened. And I want to write it in a reduced ratio. If this sides are 3 to 6, okay, so my ratio of 3 to 6 right here is going, actually, my sides here, 3 to 6, I can reduce that, it'll be 1 to 2. Let's do 12 to 24. I can reduce that, again, that would be 1/2, 1 to 2. 9 to 36, this time it's not 1 to 2, this time it's 1 to 4. So I want to see what happens. If I have a square with 3-inch sides and I want to get 6-inch and 9-inch sides, I want to compare them. What's the conclusion we can draw regarding the ratios? So we want to compare the ratios and figure out what we can figure out about the shapes. This one's going to be 3 to 9, so the 3 to 9 is here. 3 to 9 is going to be 1/3. 12 to 36. That one will be 1 to 3. The last one here is going to be 9 to 81. I think I'll choose the right one. This one will be 1 to 9. There we go. 1 to 3, 1 to 3, 1 to 9. 1 to 2, 1 to 2, 1 to 4. Okay. Now the last one here, we want to do the 6 to the 9. So these two are what we're looking at. 6 to 9 reduces to 2 to 3. 24 to 36. 2 to 3. 36 to 81. 36 divided by 9, you get 4. Divide by 9, you get 9. You're going to get 4 to 9. So can we look at the comparison ratios in the boxes here and figure out what happens every time two regular polygons are similar and have a scale factor of A to B? A to B, the scale factor is the sides. So the ratio is 1 to 2, 1 to 3, 2 to 3. So if that's the scale factor, what's going to happen to the perimeter every time? The scale factor in pink was 1 to 2, 1 to 3, 2 to 3. The perimeter is the exact same as the scale factor in pink. So I'm going to go ahead and say A to B. Maybe I could even highlight that in pink, because scale factor is basically the ratio of the sides. I'm going to do that in pink. Now what happened to get from these numbers to these the last number? The first two to the green. What happened in each case? So looking at those examples and what's going on, we see that they're squared. We get A squared to B squared. That is going to be true every single time. So right here, I know that the ratio of corresponding sides of a similar hexagon is going to be 3 to 2. Well, that means the ratio of the perimeter has to be the same as the scale factor. So I'm going to write this as RP, ratio of perimeter, is going to be 3 to 2. It will be the same. Now the ratio of areas, I usually write it as RA. This time I'm going to square these, so area I'm going to get 9 to 4. Every single time, that's going to be our rule. So here I have a rectangular tablecloth. I'm going to pause and draw these out for us real quick. Here we have a rectangular tablecloth that's 60 by 120. We don't know the price. We do have a rectangular placemat made from the same cloth that's going to be 12 by 24, that's going to be $5. We want to compare the areas of the two, not drawn to scale. We want to compare the areas of the two to find what a reasonable cost for the tablecloth might be if we use the same amount of material. So what I need to do first is I need to figure out the scale factor. Okay, so my scale factor of the placemat to the tablecloth. So I can pick any two sides to compare because that's just going to be my sides. I can do the 12 to 60 or the 24 to 120. I'm going to do 12 to 60 because they're smaller. I end up with 1 to 5. My scale factor is 1 to 5, which is also my ratio of what? This is also my ratio of perimeter. So what I'm going to have to do for the areas, I'm going to have to now set up a proportion. When I set up my proportion, I'm going to have the ratio of area here, and I'm going to set up the proportion to the cost. I'm going to go ahead and put the placemat up top and the tablecloth down below, just to make sure I'm consistent with my proportion I set up. The ratio of area placemat is going to be 1. Ratio of area here is going to be 5. No. Ratio of area, what I just forget to do. Don't forget this, it's a really common mistake. My ratio of perimeter is 1 to 5. What is my ratio of area? What do I have to do to get here? Remember, you have to square it, so this will be 25. Square it. So the money, though, $5 for the placemat, and I don't know the amount down here. This is what I have to solve. I can do 1 times 5 is 5, 25 times 5. I can just see what happens here. Get x equals 25 times 5 is $125 for a tabletop. Now, I personally don't think that sounds reasonable. Like, I'm not spending $125 for a tablecloth. But if that's what the material costs, I don't know. Probably could get that a little cheaper. Anyway, let's go on to the next page. See, this section's kind of nice. You really just have to think of a to b, a squared to b squared. I also started highlighting some stuff on the back already. So take out your highlighters, pause, fill those in. Can you answer these questions? Try to do these on your own once they focus. Scale factor, 3a to 4b. So my scale factor is 3a to 4b. Go ahead and fill those in. My ratio perimeter has to be the same, 3a to 4b. Now my ratio of area, we're now going to square it. Now you have to square everything. 3 squared is 9, a squared is a squared. 4 squared, I get 16, b squared. So again, perimeters, 3a to 4b. Areas, 9a squared. Now, you do not always have to write all 3 of them down. You can just do the work, that's fine. I tend to like to see the setup. I like to see them and I like to write them all. Even if I don't need them all, I still write them all. Because then looking at it, if the ratio of the areas is 225 to 49, now I know that this goes down here. So what I need to do is I need to take the square root to get back up here. So the square root of 225 will be 15. Square root of 49 will be 7. And whatever that is, my scale factor is going to be the exact same thing. Remember, every single time, ratio of sides are always the same. Every time, no matter what. So, we're going to go on to the next one and graph some lines here. So go ahead and take your time. Pause it, graph your lines on your own. I'm going to get pencils to start. Okay, so our first one is in point slope form. I'm going to pick out the point right here. Opposite of 3 will be -3. Opposite of 1 will be +1. So I go to -3, +1, and my slope is +2 here. So I go up 2 over 1, up 2 over 1, down 2, back 1, down 2, back 1, down 2, back 1. I can do all as far as I can go. That's my first line. Y equals -7, x, y equals -7 right here. So it'll be all the way horizontal line. And my green one here is standard form. I'm going to use my intercepts for this one. If x is 0, y will be 7. If y is 0, x will be negative 5. So 0, 7 up here, negative 5, 0 right here. That gives me a slope of negative a over b, 7/5. Up 7 over 5, down 7, back 1, 2, 3, 4, 5. There's kind of a wonky little triangle. It's a little bit tricky. I would probably do area first here. Area is going to be equal to 1/2 base times the height. So the base, you can kind of count right here. We get 1, 2, 3. And the height is going to be 7, and 7 will be 14. Area is probably going to be the easier thing to discover. Again, pause, do these on your own, come back and check. Half of 14 is going to be 7, 3 times 7. I end up with 21 units squared for my area. Perimeter is going to be a little bit tricky. I am probably going to create a rectangle around the outside. Now there are definitely different things you could do here. You could find the area of the rectangle and subtract the two triangles there. I probably did something, oh no, that would be for area. For perimeter, never mind, I'm going to use Pythagorean theorem. I was thinking area again, but we did just find area. You could do the area the way I just described. Find the area of the rectangle and subtract the two triangles. If I want to find perimeter, this is going to be 7 times 14. This is going to be 10 times 14. I need to do Pythagorean theorem for both of those. So 10 squared plus 14 squared equals c squared. I end up with 296 square root. It's going to be 4 times 74. I get 2 root 74 for this side here. So this side right here is going to be 2 root 74. The pink line is going to be 7 squared plus 14 squared equals c squared. I'm doing my Pythagorean theorem, 7 and 14. I end up with 245 square root. That perfect square factor will be 49 times 5. It will be 7 root 5. So this side here is 7 root 5. I cannot add those together. Those are not like terms. They don't have the same radical. And this side right here is 1, 2, 3. So if I'm going to add all three sides here for my perimeter, I'm going to write it below. I'm going to get 3 plus 7 root 5 plus 2 root 74, and that would be units. So classifying this triangle, none of the sides are the same. This will be scaling. And we have an obtuse angle right there. Okay, the last question here is a ACT type prep question. You want to know, given this is a factor of this, determine the value of m. So what I would probably do is, I know if I were factoring this, and one of them was x plus 4, this would be x. No, this would have to be 2x. Sorry, x plus 4, this would have to be 2x. You're going to have a plus at the end. How are you going to end with a 2m? So I know right here that if 4 times 2x will give me an 8x, and I need to get it to add up to here. So x times what is going to give me the 11x? X times 3. I think this has to be a 3. Right? Now, if that's the case, I need 2m to be equal to, so if this is a 3, this will end up being 12. 4 times 3 will end up being 12. 2m has to equal 12. M would have to equal 6. I think B is going to be my answer here. Pause it, look through it, go again. You can't even see my screen. So I figure out what does that have to be. That would have to be a 3. 4 times 3 would have to be 12. So this 2m here would have to be equal to 12 at the end for that to work, me making the M6. Again, those are just kind of some of those questions you have to work through. And I did a little bit quick for time. Have a fabulous day. Good luck. See you next time.